Thank you. Here's problem number 23 from section 9.4. So, interval of convergence?
Ratio test.
Very good. So let's handle that first. Let's find the interval of convergence for the ratio test. All right. So, applying the ratio test. I must really mean that I want you to write that down every single time.
Wow. Just subtle hints.
Okay. Limit as n approaches infinity of absolute value of
X minus 1
x minus 1
to the 2n
to the 2 quantity n plus 1. 4 to the n plus 1. 4n on top.
X minus 1 to the 2n.
X minus 1 to the 2n on bottom. All right. So there we have that. Is there any canceling? Well, when I look at the 4 to the nth and the 4n plus 1, looks like I have a 4 in the bottom. Look at that. When I look at x minus 1 to the quantity to the 2n plus 1 and the 2n plus 1, it looks like it's going to be an x minus 1 quantity squared indeed up on top. Okay. We good with that? All right. Now, this no longer has any n's in it. So this is actually equal to the absolute value of x minus 1 quantity squared over 4. And now we have to ask, when is that less than 1? Well, let's find out. The absolute value of x minus 1 quantity squared over 4 is less than 1 when negative 1 is less than x minus 1 quantity squared over 4, 1.
Divide all three sides by 1/4.
Sure.
Or just
Or multiply by 4. It's same difference. X minus 1 quantity squared 4. Right?
Square root all three terms.
You got a negative.
Yeah, that's a problem.
What do you mean square root all three terms?
Oh, no.
It's not a good side.
Look at how happy Mr.
Well,
Incorporate
the
I.
absolute value of x minus 1 squared is less than 4 squared from there,
Okay.
right?
Okay.
Reduce
All of-
imaginary number I.
All of the values here are positive. Right? All of the numbers here are already greater than negative 4.
So it
Just get rid of that.
So it then is between 0 and 4.
So as long as it's
Yeah.
It automatically becomes changes that interval from 0 to 4
The
because all
lowest you
values
can
are
have-
either positive or 0.
Is 0.
and this is and
would have to be.
what I want to look at real quickly. I want to look at this graphically just for a second because I always hit the stumbling block, and I think it would be nice if we looked at it graphically for just a second and see if we learn anything. Okay, I'm going to do something. I'm going to put up the line y equals 1. And I want to look also at the function x minus 1 quantity squared divided by 4. And I just want to look at those two things simultaneously. Okay, where's the area that I want to be in? I want to be in where the function
It's less than 1.
is less than 1.
So from negative 1 to 3.
So it sure looks like it's from negative 1 to 3.
Intersect.
Okay, well, no, No, you have to understand what I really want to do is I want to not have to go to that graph. I want to be able to create a procedure. Okay?
We do what Sarah said, since we know they're all positive values. Go from 0 is less than x minus 1 squared is less than 4.
The smallest number that quantity x minus 1 squared can take on is 0. So
Well,
I also agree with Sarah in that you should replace negative 4 with the true value of 0.
okay. I've got a. I would like to attack this slightly differently.
We can't prove that algebraically.
Well, certainly the take the number over to the side doesn't seem to work here because of the square rooting the negative number. Okay, so can I look at this slightly differently? And can I say, I want to look at that problem right there for just a second. Right? Can I solve that for x?
Yeah. 3.
Well, multiply both sides by 4. You can square root both sides now.
Positive negative 2.
And I get a plus or minus 2 there, right? Can I add 1 to both sides? 1 plus or minus 2. Now, what does that mean for me? Well, it means that if I create a number line, there are 2 values that satisfy this equation. One of them being 1 plus 2, and one of them being 1 minus 2.
Well, there you go.
Okay, now there is an area in which this, well, let's just say it this way. When x is really, really big, this expression is much bigger than 1. When x is really, really small, meaning large and negative, and then when I'm in between, I satisfy that. So from the squares where we can't do that other stuff easily, can we think about this as being kind of like finding roots? Can we do that? Okay. So for what values of x is this expression, the absolute value of that expression less than 1?
From negative 1.
From negative 1 to 3.
So when it's asking for the interval of convergence, x has to be between negative 1 and 3?
Yep.
Negative 1 is less than
Okay, now a couple of other things should jump out at you. This interval of convergence between negative 1 and 3, it has a center.
1.
And does that match the power series that's listed there?
Yes.
Yeah.
Great.
Okay. So when we're less than 1, so it's jiving with our answer that way. Yeah.
Go to the bathroom. Maybe we
Then
see
write out your
Sarah's
thing and
method works.
I'll send you on your way. All right. Now. Okay. Zach.
So by pointing out back there in the original equation, the center is at 1, can't we just take that information and bring that to the end without penalty steps?
Well, if we did,
Yes, but we still have to find the radius of convergence to know what the limits are.
Yeah.
if we had gone about how I was thinking of it by replacing negative 4 with 0, we still would have gotten the same interval.
That's true.
Because it would have ended up being x minus 1.
No, but if we did Sarah's method, what we have to do, it'd be from 0 to 4, and then it'd be plus 1 on each end, so it'd be a round interval.
Let's try it and find out.
Okay. So if we would have done it, it would have been 0.
X minus 1 to 4. Would it be plus 1 then, and it would be the right interval?
X minus
Yeah. I think there's,
So we end up
and then we end up with 0 to 4. That's x minus 1 squared, and then this changes into a 2, and that changes into a 0. and that's an x plus 1.
Now it's next minus
X minus.
Sorry, x minus 1. And then when we add 1, we end up with 3, which is good. And we end up with 1, positive 1, which is not negative 1. And that's where I was like, oh no. It's not
But weird. I know it's not a.
all right. So, but we've got to finish this problem. We found the interval of convergence. Now, can we find the sum of the series? Now, just like I want you to have a Pavlovian response to radius of convergence or interval of convergence, I want you to have a Pavlovian response with the expression sum. We only know how to find one kind of sum. And it's only on series that are geometric. Yes?
So then, to like set it up, you just do 1 minus r in the spaces, x minus 1 is 4.
Well, I'm going to do a couple things before we get there, but yeah, I think that's exactly right. Okay, I'm going to wipe out this part so we can work on what is the sum of the series, if you don't
Here, do
mind.
that with your finger.
It'd be nice if it worked, period. Sorry, one more time, but maybe more slowly.
The thing with the finger is that your finger gets this weird feeling.
Oh no, you missed the spot. 2.
Oh, no.
Yay, thank you.
All right.
Nice
All right, now, if we started writing out what this series looks like, what would the first term of this, what would the first term when n is 0, what would it look like?
1.
Well, I get x minus 1 to the 0th power. I get 1. I get 4 to the 0th power
1.
divided by 1. So the first term is 1. Okay, what about the second term?
X minus
So this is
1
when n is equal to
squared.
1. I end up getting x minus 1 squared divided by 4. And what about when n is 2? I get x minus 1 to the 4th over
4 squared.
over 4 squared. So we could say this is a geometric series with a equals 1 and r is equal to
X minus 1 squared over 4.
x minus 1 squared over 4.
What? They did that yesterday too, didn't they?
Therefore,
Where's that last hour?
Therefore, when it converges to 1 over 1 minus x minus 1 squared over 4. Now, probably they clean that expression up. Maybe they find a common denominator of 4, and you get 1 over 1 minus x minus 4 squared over 4, but then this is a 4, so you get the common denominator. So the ending answer is probably 4 over 4 minus x minus 1 squared. Do they leave it like this?
No, they went further and actually foiled the X minus 1.
All right.